Today's lesson is about Introduction to Inverse Trig Functions. Discussion: do all the functions have inverse functions? Answer is no. Only one-to-one function has an inverse function. Then how to check a function is a one-to-one function? We use horizontal line test to decide a function is a one-to-one function or not. Let's recall vertical line test. We use vertical line to test whether a graph is a function or not. Let's look at the first graph. First of all, use a vertical line to test this graph is a function or not. We found two intersections. That means it's not a function. For second graph, every vertical line has only one intersection, means this is a function. Let's test the third graph. Only one intersection means a function. So for second and a third graph, are they one-to-one function? We got to use a horizontal line to test. We draw a horizontal line. See, we found the two intersections, means it's not one-to-one function. Let's go to the third graph. I draw a horizontal line. For any horizontal line, only one intersection, so this is a one-to-one function. Let's go to question 3. Is sine a one-to-one function or not? What about cosine and a tangent function? Let's look at the cosine function first. Do the horizontal line test. See, we got more than one intersection, which means it's not one-to-one function. Let's go to sine function. Still, I draw the horizontal line. Still, you got more than one intersection. That means it's not one-to-one function. For tangent function, we use a horizontal line test. You could see you have more than one intersection. Means tangent function is not one-to-one function. But today's topic is an inverse trig function, which means for sine, cosine, and a tangent, they do have inverse function. How could that happen? There is a way to make cosine function and a sine function, tangent function, into one-to-one function. By restricting the domain, we can make sine, cosine, and a tangent function into one-to-one function. How do we do that? For sine function, when we study inverse function of a sine function, we restrict the domain into negative pi over 2 to pi over 2, which means we only find the inverse function for this portion of a sine function between negative pi over 2 to pi over 2. For this portion, we do a horizontal line test, and we know this is a one-to-one function. As we know, any function will be reflected across a. So how to graph inverse function? There are two ways to do this. First of all, you can switch all x and y value. That means for original function, I have x, y, then I can switch into yx. Then you will get the inverse function. Or you can make original graph reflect over the line y equals x. Anyway, we need to draw y equals x function. This is a y equals x function. Then you can make this portion of negative pi over 2 to pi over 2 reflect over this y equals x. I will find some points on the sin x for given domain. I will draw line perpendicular to the line y equals x for each point. Then I extend. Make sure this is the same distance. For this point, we do the same thing. Perpendicular line, then it's the same distance. Then we connect these points. This will be the inverse function. Y equals inverse of sin of x. Also, we can switch x, y, and then sketch the inverse function. Let's make a table. We have x, y. 0, 0. For pi over 4, sin pi over 4, we got square root of 2 over 2. For sin pi over 2, we got 1. For negative pi over 4, we got negative square root of 2 over 2. Negative pi over 2, we got negative 1. Then we switch x, y, we got the following coordinates. Negative 1, negative pi over 2. Negative square root of 2 over 2, we got negative pi over 4. Then we got 0, 0. Then we have square root of 2 over 2 pi over 4. Then we have 1 and a pi over 2. So let's plot these points. We got negative 1, negative pi over 2. Negative square root of 2 over 2, that's kind of a negative 0.7. So negative 0.7, then it will be half of this. Yeah, get over here. Then 0, 0. 0.7, then it will be half of that. Estimate here. Then 1 is pi over 2. So we can sketch the graph like this. this will be y equals inverse sine of x. This inverse sine function graph is more accurate. If we want to use unit circle to show inverse sine function, we could say that the range for inverse sine function will be between negative pi over 2 to pi over 2. Let's talk about properties of inverse sine function. For the domain range, we can go back to sine function. We know for sine function, we restrict the domain of a sine function into negative pi over 2 to pi over 2. Range will be from negative 1 to 1. Therefore, for inverse function, we switch domain range. Then domain will be between negative 1 to 1. Range will be from negative pi over 2 to pi over 2. Symmetry. For this inverse sine function, it's symmetrical across the origin, 0, 0. For maximum value, that is pi over 2. Minimum value, negative pi over 2. 0 means x-intercept, that is 0, 0. No asymptote line, so I put the none. Let's go to cosine function. Still, you need to restrict the domain of a cosine function to make cosine function into one-to-one function so that we can get the inverse function of a cosine of x. The domain will be restricted as 0 to pi. That means from here to here. You can sketch inverse function by reflecting over y equals x. Or you can get a more accurate graph by switch x and y value. Let's switch x and y value. For cosine 0 equals 1, cosine pi over 4, we got square root of 2 over 2. Cosine pi over 2, that's 0. Cosine 3 pi over 4, we got negative square root of 2 over 2. And cosine pi equal to negative 1. We can get the following coordinate by switching the x and y value. We got 1, 0. Square root of 2 over 2 pi over 4. 0 pi over 2. Negative square root of 2 over 2. 3 pi over 4. Then we have negative 1 pi. This one will be pi over 4. This will be 3 pi over 4. Let's plot these points. We got 1, 0. Square root of 2 over 2, that's 0.7. Will be pi over 4. And 0 pi over 2 is here. Negative square root of 2 over 2, kind of like negative 0.7, you got 3 pi over 4. Then for negative 1, you got a pi. So we connect these 5 points. That's the graph for y equals inverse cosine x. This is a more accurate inverse cosine of x graph. If we want to use unit circle to show the range of inverse cosine x, that will be between 0 to pi. Let's study the property of inverse cosine x function. For domain range, we go back to y equals cosine x when we restrict the domain into 0 to pi. So we got the domain that's between 0 to pi. For the range, that is from negative 1 to 1. Therefore, domain of inverse cosine x function, that is negative 1 to 1. Range will be between 0 to pi. For symmetry, we don't have any symmetric line for that. For maximum value, that's pi. Minimum value is 0. For zeros, that is 1, 0. That's x-intercept. No asymptote line. Now let's go to y equals tangent x function. This is a graph for y equals tangent of x. We still need to restrict the domain into negative pi over 2 to pi over 2. Remember this open parenthesis because for tangent of x, x cannot be negative pi over 2 and a pi over 2 because that's undefined. Now we will set up that table so that we can switch x and y value. We have x, y. Tangent 0 equals 0. Tangent pi over 4, that's 1. Tangent negative pi over 4, that's negative 1. Pi over 2 will be undefined. Negative pi over 2, that's undefined. So we got the following coordinates: 0, 0, 1 pi over 4, negative 1, negative pi over 4, undefined pi over 2. Then we have undefined negative pi over 2, which means for pi over 2 and a negative pi over 2, you got the asymptote line, like these two. This is a horizontal asymptote line. Now we plot the points 0, 0. For 1, that's pi over 4. It's here. Negative 1, negative pi over 4. That will be here. This is the one. So we connect these points, make sure very, very close to asymptote line but never touch. Therefore, I will sketch the graph like this. Here is a more accurate inverse tangent function. If we want to use unit circle to show the range of inverse tangent function, it will be between negative pi over 2 to pi over 2. Remember, this is an open circle, means not included. Now let's study the property of inverse tangent function. For y equals tangent of x function, we know that domain will be between negative pi over 2 to pi over 2. That's open parentheses. It's not bracket. For range, that is all real numbers. Therefore, for domain, that's all real numbers. Range will be between negative pi over 2 to pi over 2, open parentheses. Symmetric across the origin, 0, 0. For maximum value, no, we don't have a maximum value. That's very, very close to pi over 2, but never reach that value. Minimum, still no. Zeros, that's the x-intercept, that's 0, 0. We do have asymptote line, that is y equals plus or minus pi over 2. Let's draw a conclusion for inverse sine, cosine, and a tangent function. This time, let's label, here's 0, pi over 2. This is pi. But we won't label this one as 3 pi over 2. We label as negative pi over 2. We still call this is 1, 2, 3, 4 quadrant. For inverse sine, cosine, and a tangent function, if domain is a positive x, that means the range will be between 0 to pi over 2. When the domain for inverse sine and a tangent function is negative, then the range will be between negative pi over 2 to 0. When the domain for inverse cosine is a negative number, then the range will be between pi over 2 to pi. In other words, when domain for inverse sine, cosine, tangent are positive, then range will be reference angle. If it's a special angle, then the value will be 0, pi over 6, pi over 4, pi over 3, or pi over 2. The pattern will be pi over n pattern. When domain is a negative for inverse sine and a tangent function, then the pattern will be negative pi over n, which means negative pi over 6, negative pi over 4, negative pi over 3, or negative pi over 2. When the domain for inverse cosine is a negative, then the pattern will be n minus 1 pi over n. In other words, we will have 5 pi over 6, 3 pi over 4, 2 pi over 3, or pi. When you're working on the value of an inverse function, have this pattern ready, like pi over n minus 1 pi over n, or negative pi over n.